Um, Hello everyone. So today, before look at our question 23, we firstly look at conclusion. So here is a big circle A, OB, right? O is the center of the circle, and AB is a kind of diameter line. So if I randomly point one dot C on the circle, for example, I put the C here, and I connect AC, AO, AC, CO, and CB. So what can we calculate the angle of ACB? Let's have a look. So because of OA, OC, OB is radius, so OC equals to OA equals to OB. That's right here. Which means the triangle AOC is a kind of isosceles triangle. So let's name it angle 1. So this one is also angle 1. Use the same method, OC equals to OB. So this one is angle 2. And also this one is angle 2. Let's have a look. So we know angle 1 plus angle 1 plus angle 2 plus angle 2 in triangle CAB. We know the integral angle of a triangle is 180 degree, right? Which means angle 1 plus angle 2 plus angle 1 plus angle 2 equals to 180 degrees. So we have 2 angle 1 and 2 angle 2. So which means angle 1 plus angle 2 should equals to 90 degrees. Which means no matter where we choose this C point on this circle, the triangle, we still have a triangle ACB. And the triangle ACB is a kind of right angle triangle. The angle ACB is 90 degree. Okay, here this is a very famous construction. It's called Taylor's theorem. And in geometry, Taylor's theorem states that if ABC are distinct points on a circle where the line AB is a diameter, the angle ACB is a right angle. Okay, remember this? Let's look at our question 23. In question 23, yeah, we still have a diameter AB, and C is a randomly maybe, C is the a center on the circle, which means, yeah, firstly we know angle ACB is 90 degree, and because C is the center, right? Which means the graph is a kind of high symmetric graph, which AC should equals to BC. Of course, AC equals to BC, or you cannot draw a sector, right? So we need to find out the whole shape's area. It's very easy for us. Firstly, let's find out semicircle ABC's area. Actually, it's pi r squared, right? So r equals to what? Is half of the diameter. So actually is pi times 10 squared n divided by 2, because pi r squared is a whole circle. This one is a kind of semicircle, so the answer is 50 pi. And also, let's look at this ACB sector. So ABC sector, we know this one is 90 degree, so it's just a quarter of the whole circle. Of this circle, the radius will become AC. So the sector ACB is pi divided by 4 in times AC squared. And also, we need to calculate this right angle. Actually, this one is a kind of isosceles right angle triangle, ACB. Also, you can just, AB is 20. You can just calculate BC is root something, but I not suggest that. So not all guys know about how to calculate root. So the triangle area of ABC is just the AC squared over 2. Now let's look at how we can find out AC squared. This seems is a very important thing. And we know AB is 20 and ACB is a kind of right angle isosceles triangle. Isosceles right angle triangle. Maybe you can put here. So ABCD is a kind of square. Also, you can use the some conclusion, some result of the square. So we can find AC square is just the AB square divided by 2. Okay, so we have know all the things. So the inner shape is just use semicircle ABC, this part, plus the sector ACB, this part, and what's the overlap? This isosceles right triangle. So minus this isosceles right angle triangle, ABC, actually is 50 pi plus pi over 8 times AB squared. I put AB squared instead of AC squared, and minus AB squared over 4. So the answer is 214 centimeters squared. Basically, this question is not so hard, but you need to know the angle ACB is a kind of right angle. This is a very important solution in when we calculating some question about circle. Yeah, this is a very famous theorem, and I hope all you guys can remember it.